We have Arya online and 4 of you. So either Arya is there or Shraddha is there. Is there any understanding between you? Oh, somebody is waiting. Who is that? Okay, so we have Jamshed, Shraddha, and Arya online, and 4 of you. Okay, please sign the attendance. All right, am I audible to online students?
Yes, sir.
Okay. So we have already started electricity and covered quite a bit, right? So we have covered till potential difference. Till potential difference. So right. So we have started with electricity. We have defined electric current. Okay. So we defined electric current as rate of flow of charge. Charge flowing per unit time was defined as current. Right? And the unit was ampere. You're already aware of it. So what is 1 ampere? 1 ampere is 1 coulomb per second. Right? So how? But we also understood that if this is the conductor, right? If this is the conductor, then what is current? Current is the charge flowing across the cross section. Okay, few amount of charge flows in time t. That's when we call current is equal to charge flown per unit time across the conductor. Okay, so this is the conductor. Right? Now, but what is the direction of electric current? What are these nature of charges? These charges are basically electrons. So if electrons are flowing from left to right, then we take the direction of current as right to left. What is the direction of current? Opposite to the direction of electrons, right? So direction of current is opposite to direction of electrons. So this we covered already yesterday, right? And this direction is taken opposite to direction of electrons by convention. Okay. What is the convention? I will explain sometimes. Sometime in the future. Charge is negative on electron. Then, yeah, so equal and opposite. So it is positive for I. Because when negative charge is flowing to the right, we assume that positive charge is flowing. It is not flowing, but we assume. Because overall charge is 0. Net charge is 0. That's why. So that's why it is also called as conventional current. Current direction. Okay, so these are some of the things that I think some students missed yesterday. Okay, so next, after electric current, we define potential difference. Potential difference. See what causes the current to flow in the conductor, right? So you require some source of current, which is cell. So when the potential difference is applied, right, this is the cell which offers potential difference. Right? So because of potential difference, potential is like electrical level. So at the positive side, the level is high, and at the negative side, the level is low. Right? No. So will the electron flow in that direction? It should be like this. Right. So there it will be minus, and here it will be plus. So plus means high electric potential. Right? Understand in terms of level. Remember water level. So whenever water is at high level, it will flow always from high to low. So that's when the electric current always flows from higher level to lower level. Now you understand why are we taking conventional current direction? Because in real life we always see flow or current takes place of anything from higher level to lower level. If I leave this pen from a higher level, only then it comes to lower level. So this is the general experience. But in case of electricity, the charge were flowing from in the opposite direction. So electric charge, because opposite charges are attracted. So plus will attract minus. So electron is flowing towards higher potential, right? But then we take therefore by convention current as higher to low. Is this understood? So this is low electric potential.
The sum of this.
One second. Okay. So whenever you have so when will the electron flow or the current conduction will take place? Whenever there is a potential difference applied across the conductor, right? Now, what is this potential difference now? So we define potential. How did we define potential? Potential at a point. So potential at a point was defined as work done in bringing a unit positive charge, right? So it was defined as work done in bringing a unit positive charge from infinity to that point, right? So it's basically work done in bringing unit positive charge from infinity to that point. Which point? Where we want to know the potential or the electric level. Okay. So it is the work done in bringing unit positive charge from infinity to that point. So work done per unit charge, right? And so is potential difference. What is potential difference? So I advise those who missed to go through the video lecture. Okay, I have explained in detail what is potential at a point and what is potential difference between 2 points. Okay, so what is potential difference? This also is given as, now this is work done in taking a unit positive charge between 2 points. Okay, so potential difference between 2 points is difference between 2 points is work done in taking a unit positive charge between those 2 points. Right? For example, if I am working in taking electron from this terminal to this terminal, I will do some work. Okay? So I am depositing electrons on this terminal. So the existing electrons on this terminal will oppose whenever I am trying to bring electron from here to here. So this is what the electrolyte in the cell does. So when the potential difference is developed, right, the chemical reaction between the electrodes of the cell, right? So in that the chemical energy is involved in depositing the electron from here to here. Understood? That's what the work is, and that work is stored as potential energy of the cell. So it is electric potential energy. So we know. Huh? Yes, always.
Positive charge minus of minus electrons.
I didn't get your question. What are you trying to say?
So we write the example potential difference from the positive terminal to the negative terminal, then the positive terminal charge minus of minus electrons.
Yes, the deficiency of electron is making that positive.
So that will be positive.
Yeah, because overall charge is 0. When you see, like in mechanical potential energy, when let's say this is ground, okay? This is ground. When I keep the pen on the ground, does it have any energy? When I create some difference in the level, now it has energy. How it got the energy? I worked on it. So when I worked on it, my working got stored in its pen, in this pen as energy, mgh. Okay. Likewise, who is separating the electron? Now let us say these are 2 terminals. Okay. 2 electrodes of the battery. Who is taking the electron from here to here? The electrolyte in the cell. So electrolyte is working now. So the chemical energy is working in separating the electrons from the anode to cathode, let us say. So now, once the separation is there, what is electron trying to do? At the first opportunity, it will try to go back to positive terminal. But the chemical reaction is not letting it do. So as long as I am holding it here, it has energy. The moment I release, it will go. So chemical reaction is not letting the electron to recombine. So how will it recombine? The moment it gets any conducting path. You understand? The moment it gets any conducting path, it travels through the load and reaches the potential. You understand? So it's that only. So here this is electric potential. In this example, it is mechanical energy, which has potential energy, which is in which form? Mechanical. Likewise, in spring, In spring, you have elastic potential energy. So there are a couple of, like 3 examples of potential that you will study. Gravitational potential. Okay, this is gravitational potential, which I got mechanical. Then you have spring potential, which is elastic potential. Now you have electric. So everywhere you are working against some force. You are working against electrostatic force of repulsion in this case. You got it? Okay. Now what is the potential difference expression for this? Also it is same only. E is equal to W by Q. Now this V is work done only between 2 points. Say A to B. Whenever work is done in bringing unit charge from B to A, that work is defined as potential difference. Here it is potential at a point, here it is potential difference between 2 points. Okay. Now, what is the unit for potential? Unit for potential is volt. Unit is volt. Volt. Right? Solve this. So, what is 1 volt? When 1 joule of work is done in bringing 1 coulomb of charge between 2 points, then we call that potential difference as 1 volt. Is that clear? All right. So, with this, now I will proceed further. Apart from this, we had discussed electric circuit, right? And we also discussed some components of electric circuit with their symbols. So, just go through the video. Okay. What we did just now was only the revision, right? So the next point is, what is the next topic? ऑनलाइन 3 बच्चे हैं, श्रद्धा, जमशेद और आर्या. Okay, so the next topic is Ohm's law. Right? Now, consider this circuit for understanding Ohm's law. You have cell, then you have a plug key. Now, this is how the resistance of the conductor is shown, right? And to measure the electric current, we require some instrument. What is that instrument? Ammeter. Okay, we need this to measure electric current. Now the bigger terminal is positive or higher level, so that is bigger. This is negative, right? So this is how our electric circuit is complete. This is our resistance, right? How do we measure the potential difference? We connect a voltmeter. Okay. So what is the polarity? Negative this side, positive this side, all this, positive and negative. Okay. So this is the circuit, right? Now what is Ohm's law? So this is the simple circuit. With the help of this circuit, we'll understand. Ohm's law says this R is the resistance of the load. Right? It could be electric bulb, it could be conductor, whatever. Okay. So what Ohm's law says is, whenever potential difference is applied across a conductor or a load, right? The current in the load is directly proportional to potential difference applied, as long as its temperature remains constant. Okay. So what does Ohm's law say? It states that the current flowing through the conductor Yeah. So the conductor, that is resistance. I'll explain what is the meaning of resistance. Going through the conductor is directly proportional to the potential difference applied across it, provided its temperature remains constant. Okay. So what is Ohm's law? It says if we increase this potential difference, let us say I put a cross sign. That means it is a variable potential difference, right? What does this sign means? I can vary. I can start with a zero potential difference. Now I can increase it, right? So whenever I increase the potential difference applied across the conductor, the current through the conductor will increase. Okay, how can we check that? We are slowly increasing the potential difference. Look here, we are slowly increasing the potential difference. Then the current increase will be registered here or witnessed here, right? The increase in potential difference across this conductor will be seen as in this meter. Okay, in the voltmeter. So M meter will tell me how much current is flowing, and B will tell me what is the potential difference across the conductor. Got it? So this is the experimental setup to study Ohm's law, right? So it states that the current flowing through the conductor is directly proportional to the potential difference applied across it, provided its temperature, resistance of the conductor's temperature remains constant. So now we'll write it mathematically. That is, I is directly proportional to E. Okay. So now we will replace the constant. So I is equal to E by R. Right? So what is that constant? Let's solve. E is proportional to I. We can write it. If the current depends on V, okay, that means there is a direct proportion. So whenever there is a direct proportion, I can write it like this. Therefore, E is equal to constant I. That constant we call as resistance. Right? Where R is constant of proportionality. Or resistance of the conductor. Okay. Right. Right. So when we take various readings, right, and plot the graph between V and I, right, so what are we varying? We are varying the voltage. There is 0, 1, 2, 3, 4, 5. Right? So we're getting the current in milliamperes. Let's say current is in milliampere. Right? So we have 10, 20, 30, 40. Okay. So what do we see? Right? When the voltage was 0, no current was flowing in the circuit. Okay. So when the voltage was 0, no current was flowing. So what is my first point here? So let us record the data. Okay. In this. When I did the experiment, right? So I recorded the value of V and I in these meters. When I kept V0, I found no current in the circuit. So when I saw V0 here, it was also 0. Now when I increased this to V, it is the volts, right? So when I increased V to 1 volt, I got the current as 10 milliampere. How much I got? 10 milliampere. I can see it in the meter, right? When I increase it to 2, I got 20 milliampere. 3, I got 30 milliampere. Likewise, at 4, I got 40 milliampere. Okay. So now I will try to plot the graph E on the x-axis and I on the y-axis, or either ways, because this is in direct proportion. Okay. So what is the nature of graph I am getting? So V0, I0. This is the first point. V1, this is 10, right? This is the second one. 2, I am getting 20. 3, I am getting 30. So when I kept the voltage at 4, I got 40 MV, 40 milliampere, right? So what kind of graph will I get? I'll get a straight line. So when the scale is proper, I will get a straight line, right? Get a straight line. Okay. So this is called IV or VI characteristics. Okay. So this is the experiment which we did for verification of Ohm's law. So since we are getting a straight line, so it verifies that V is directly proportional to I. Okay, there is a linear relation between the voltage and current, right? So this is the verification of Ohm's law. Is it clear? So any question here?
Is the potential difference between the negative terminal and the any point after resistance 0 and they have the state potential as the resistance?
So you asked me the same question yesterday also, right? So there is a current flow, so there has to be potential difference. So if the current is flowing in this direction, current always flows from higher level to lower level. So anything above it will have higher potential, but very minor difference if the points are very close. Right? From here to here, the resistance is almost 0, right? Because it is a conductor. So now we'll understand what is a conductor, what is an insulator. So in case of a conductor, the resistance is 0. So where is the resistance? It is in the load. Okay. So you can virtually say it is negligible potential difference. Why? Because resistance is 0. If R is 0, V will be 0. Look here. V is equal to Ri. If the resistance is minimum, then the potential difference across those points will be minimum. So where is the maximum potential difference? Across the resistance. Yes. Got it. Because for me this resistance is connected over here. So this is just to show you the diagram. Otherwise, this point is same as this point. Are you getting? Yes. Whenever we attach the voltmeter, yeah, voltmeter will always measure the potential difference across the load, which is our resistance. So it will depend what is the potential difference applied. So I am increasing, it is variable, right?
So if we put the voltmeter in the middle of the circuit and
Here,
then
how does it matter?
it is
Yes, it will be same here also. See, this point, either here or here, it is same point. This point, when I put here, it is still across the resistance. Right? Just this ammeter, I will take it here because ammeter might have some more resistance. Listen, if you connect, what I have to do is cross. Meaning? Come, what do you want? Come. Rather than explaining, you do it.
So from this point to
this point, it will show what is the potential difference across the ammeter. That's what it is.
so this is current across the entire circuit.
So it always measures the potential difference between the 2 points. It will not now show what is the potential difference across them.
So this is current between the whole circuit constant.
Yes. So what happens is the current is how the current is flowing. Current is flowing from here to here. Then it is passing through the resistance through the ammeter like this. So current is flowing in this circuit. This is our electrical circuit. Now the voltage meter resistance is very high. So current will not enter here. So basically, what is resistance? We have not yet defined. What is resistance? Resistance is offers opposition to flow of current. Okay. So we need resistance to regulate current in the circuit. Like if you want to increase the speed of the fan, so we will reduce the resistance in the path. If you want to slow down the fan, then we will increase the resistance. Okay, so once we increase the resistance, less current will flow through the fan, and the bird's speed will be reduced. Understand? So resistance offers opposition to the flow of current, and its unit is ohm. Symbol is this omega. Okay, what is the unit of resistance? Ohm.
So this omega is equal to ohm or resistance.
Huh?
Omega is equal to ohm.
Sorry.
Resistance.
Resistance, this ohm, okay? That's the unit of resistance. This symbol is written as omega.
Omega is equal to ohm or resistance.
Yeah, for resistance itself. No, resistance symbol is this. Its value, like 10 ohm.
So R is equal to 10 omega.
Yeah, 10 ohms. Yeah, either you write 10 ohm or you write 10 omega. This is 10 ohm. So it's a very low value of resistance. Right?
Yes. So the resistance changes the potential across, but the current remains the same across.
Yes, the current remains the same in one loop. As long as the loop is same. See, the voltmeter has a very high resistance. This is how it is designed. So voltmeter is measuring this potential difference. So some of the current should not travel here. Otherwise, it will measure a wrong value. So the current is made to flow through the circuit only. It never enters the voltmeter. Okay. So therefore, what was the question?
So the resistance the resistance changes the potential between the 2 points, but it doesn't change the current.
Yes, because V depends on the resistance, right? And current will change. See, resistance basically will change everything. It will become clear. Just wait for some more circuits to come. Right now, you understand what is potential difference, what is current, what is resistance. Are these three things clear? What is potential difference? It is needed for the current to flow. Okay. Now, current is what does electrical work for us. If there is no current, no working you will see. Okay. So, as long as current is flowing in the circuit, right, all the electrical devices will work for us. Is this clear? To flow the current, we require potential difference. Is this clear? So, V and I is clear. Now, how much current should flow? For that, we need resistance to regulate the current. All devices don't need same current for its functioning. You understand? Some will work at lesser current. So how do we control the current? Because the same power plant is sending electricity everywhere. So we are getting 230 volt AC in our house or 220 volt AC. But all devices don't require 230 volt. We reduce it. For mobile, it works at only 5 volt and DC. It's not AC. So hold on. We will cover everything. First, what is potential difference? What is current? What is resistance? Are these three things clear? So what is potential difference? Source of current. If there is no potential difference, no current in the circuit. What is resistance? Obstruction to current. So it is needed to regulate the current. Okay. And this is the relation between all three of them. The relation which connects potential difference, current, resistance is called Ohm's law. Is that clear? Any question, online students? No question, give me a thumbs down.
No questions.
Okay, Shraddha has no question, Jamshed no question. All right. So, is it clear now? So, linear relation shows V is directly proportional to I. Now, can you find resistance from the graph? How to find the resistance of the conductor? So we find the slope, right? So when we find the slope, what do we get? So we'll get I by R, right? For this. Yes. Okay. The slope is I by R. Right. Therefore, R will be equal to I by V. Yes. So it will delta I upon delta V. So R will be 1 by slope. So reciprocal of the slope will give me what is the resistance of the conductor. Is it understood? Okay. All right. Note down. Is it noted? Everybody has noted it. Can I erase?
No, sir.
अच्छा ठीक है नोट करो फटाफट So let me know if you have any questions. What is this? Data, accelerated data. So what is this? E, you write this simple. E. Correct. I. Show I. I forgot to show I. So current is I. Current is always from positive to negative outside the cell. Okay? Positive to negative outside the cell. That is how the current is. Right?
Sir, done.
Okay. Oh, this is not straight. It has to be straight. is the graph? Draw the graph, right? Straight line it should be. In book, just keep emotion giving you a graph. Textbook. Ohm's law. Is the graph here? Yes. So it is asked, right? And you have to draw the graph and it should be a straight line. Okay, so now let us proceed to do some numericals. So there are some activities. Okay. No, charge the current है, milliampere. Ampere is a very high value of current. Generally, current is like in our house we have maximum current rating will not go beyond 5 or 10 milliampere or 10 ampere. When you use AC, geyser, etc., okay, that will draw higher current. But for mixer, etc., these appliances, electricity, fan, etc., so they will work at a lesser current. 0.5 ampere or 1 ampere max, like that. Okay. Okay, so let's go forward. Let us now see what is resistance. So we know that resistance is obstruction or opposition to flow of current. So why it happens? So let us see the structure of conductor. Right. So what happens is, so inside conductor, what do you have? You have a lot of free electrons, right? And a lot of ions. What is there inside conductor? So the net charge is 0. You have positive ion. Like once the electron comes out of the atom, that becomes positive ion, right? Positively charged. So in metals you have free electron. Metallic conductor. There are a lot of free electrons. Right? So now when potential difference is applied, which participate in current conduction. In current conduction, when potential difference is applied, across it. Okay, now let us say a potential difference is applied over here. So what will happen? This terminal is negative, it will push the electrons towards right. So when no potential difference is applied, all the electrons are, the free electrons are with their parent atoms. Now, let us say you have this switch. Now when the switch is hit on, then what should happen? Then all the electrons will be pushed to the right side. Okay. When these electrons start moving, right? So there is no free flow. there is obstruction in terms of crowded. This place is not free for the electron to go, right? So it will collide here. So when it collides here, maybe it will be deflected above. It will collide again, right? So sometimes, so let us say if it collides like this, it will come back again, right? But again, this negative potential will push it that side only. So it's not free flow of electron. There are a lot of collisions on the way. So this resistance is because of those collisions of electron with positive ions, right? So resistance. So this flow of electrons, of free electrons, is obstructed due to collision of electrons with the positive ions and among themselves. Right? So imagine if there is a passage and there is no crowd, you will pass out immediately. But if there is a lot of traffic, lot of other boys, so your walking would be obstructed. That is what is resistance, right? So whenever collision takes place, then it is throughout. So even though it is, it is going back, but it will be again pushed forward. So there will be net movement ahead, right? So although, right, so despite of collision, there will be net flow of electrons across the cross section of the conductor. Right? Due to potential difference. So even though they will be obstructed, but ultimately these electrons will reach here. Okay, and there will be current conduction. And what is the direction of current? Direction of current will be the opposite direction. Okay. Understood? Understood. It's like a mother is pulling the child to the school. Child is not trying to go, but still she will ultimately drop him to the school. Okay. So then it's not a free flowing motion of electron. So therefore we say electrons drift towards the other end, right?
So that's why it is the resistance because it will reduce the speed of
Exactly. So the motion of electron, since electrons are not able to flow freely, its motion is of drift nature. It is not flowing freely, it is drifting slowly. You understand? So that's why different metals, since they may have different structure, different metals will have different resistances. So it depends on the property of the conductor. Understood? Like copper will have less resistance, silver even lesser. So it all depends how the atoms are laid out. Okay? Inside the conductor. Huh? Yes, you can say that, but no, so it's organized in the group. So all these alkali metals, right, which has one electron in the outermost orbit. So more the free electron it can share, right? So only the free electrons are able to participate in the current. Are you with me? Huh? Is it making sense? So these concepts are little subtle. Okay, so you have to read and imagine and ask questions. That's the only way. This is the best I can do in terms of explaining. Okay. So do you have any question on resistance? So next topic is, and why the obstruction is. So what will happen because of lot of collision? Okay, every collision produces heat. So conductor becomes heated. So what is Ohm's law? The temperature should not rise. So it's an idealized situation. In real situation, you will never get a straight line, or you will get a straight line for a very short duration. With time, the conductor is going to get heated because collisions are never going to stop. So that's where my full electrical energy is not available to me as a work in the appliance. Some of it is wasted in terms of heat. You understand? That's the energy wastage. So the efficiency will improve if I have conductors with less and less resistance. So the research is on for building superconductors, which will have virtually zero resistance. So if you don't have resistance, then I will have unlimited energy. Because once I switch on the circuit, no heat is wasted, it will continue to work more. Okay? So that's how it is. So next is factors on which resistance depends. So there are some activities you can read and ask me a question if you have any. Next, can I erase this?
Yes, sir.
Online. Do you have any questions, online students? Shraddha, Jamshed, Arya?
No, sir.
No, sir.
So since electrons are not able to flow freely, its motion is of drifting. Okay, it is drifting. So what is the direction of electron motion? Ultimately, it is moving left to right. Shall I proceed? So factors on which resistance of the conductor depends. Okay. So it depends on two factors. It is directly proportional to length of the conductor, and it is inversely proportional to area of cross section. Right? So that is resistance is directly proportional to length of conductor and resistance is inversely proportional to cross-sectional area of right. Can I erase this?
Yes.
So combining, that is R is proportional to L upon A, or R is equal to rho L upon A. Right? Where rho is constant of proportionality. Called specific resistance or resistivity of the it is a characteristic constant. Characteristic constant for substance. For given substance. Understand what it means, so write it down.
That is, P was square. That is P was square.
It is pronounced as rho. What is unit of resistivity? Unit of rho is rho is equal to L by A, so it is meter, ohm meter. Ohm meter. So L is meter, A is meter square, so it is L by A is just meter. So ohm meter. Okay. So let us understand what is specific resistance now. You see the board velocity here. Can you see the board? Okay. So question, is resistance constant for a given conductor? Yes. What if I increase the length? So resistance increases directly with length. Okay. If I change the cross-sectional area of the conductor, then also increase. So therefore resistance is not, so resistance changes with the dimension of the conductor. Okay. But what does not change with the dimension? Specific resistance. Okay. Because what is specific resistance? It is so R will be equal to rho if L is 1 and A is 1. So what is specific resistance? It is the resistance of conductor of unit length and unit area of cross section. So that will be same for a given substance. That clear? So that is why it is called specific resistance. Right? So what is specific resistance? Okay. L is equal to 1 unit and A is equal to 1 unit. Then rho is equal to R. Okay. Therefore, specific resistance, how do we define specific resistance? Is the of a given substance or of a given conductor the material is of significance, no substance is its resistance or unit length and unit cross sectional area. Cross sectional area. That clear? So now it becomes independent of the dimension of the conductor. Understood? So now look at table 12.2 in your book, which is on page number 207. So the good conductor should have high resistivity or low resistivity? low resistivity. So the table actually, look at this table in your book. Page 207, this yellow table. So all the conductors have very low value of resistivity. See, silver has lowest 1 point. And I'm not able to hear you. What are you saying? Negative थोड़ी है यार, छोटा है ना, small. How can resistance negative? It's the power negative. क्या हुआ?
The last time it seems for 210, one last time I had minus, so it became negative.
No, it's the power which is negative, not the value. 10 to, that's the range. 10 raised to 10 to 10 raised to 40. Okay. Achha, for insulator you are saying that. No, it's the range. So you see, for insulator, the resistivity value is so high. It's a very big number, right? Whereas if you look at conductors, their resistivity value is less. Okay. But now, so I said a good resistance should not vary with, its temperature should not vary when it is in use. Otherwise, the circuit itself will start behaving differently. Huh? So that's why we have alloys. So we have to basically mix certain substances, right, and make some stable resistances. So what happens is when you heat a substance, okay, its temperature rises only for a certain time. Then it reaches an equilibrium state. So whatever heat it absorbs, it radiates it in the atmosphere. You understand? So if the heat is retained, only then the temperature rises. If the heat is not retained, then the temperature will stop rising. So alloys are such substances like constant tin. It is an alloy of copper and nickel. Okay, manganese, nichrome. All the commercial resistances are made up of these alloys. So they are very stable resistances. Okay. So do you have any questions? So resistivity of alloys is generally higher than that of constituent metals. So alloys do not oxidize, that is burn readily at high temperatures. For this reason, they are commonly used in electrical heating devices like electric iron tester. Read the paragraph above the table. Okay. So tungsten, we have tungsten here, right? It is used almost exclusively for filaments of electric bulbs, whereas copper and aluminum are generally used for electrical transmission lines. So why copper and aluminum? Because it has less resistance, so less wastage. Okay. You will now also learn when the conductor has high resistance, lot of energy, electrical energy is wasted as heat energy. Okay, we'll learn that. So are you getting some sense of what is potential difference, what is electric current, what is resistance, right? And on the basis of resistivity, we have classified substances as conductor, insulator, and semiconductor, which is not appearing. So in higher classes, we'll also learn about semiconductors, right? Okay. So you have alloys here. Instead of alloys, you will read semiconductors in higher classes. Okay. With that, now, shall we solve some numericals here? Or shall I complete the next topic, which is combination of resistance in series and parallel, and then take up numericals? Huh? Why don't we do that in the next, after the break? Okay. So in the meantime, I'll complete combination of resistances. Okay. Any questions still here? Okay. So let's do combination of resistances. Next is combination of resistances. Now, in an electrical circuit, we can combine resistance in two ways, right? Series and parallel. So, in an electrical circuit, resistances can be combined in two ways. Series and parallel. Okay. Now, what is a series connection? When one end of the resistor is connected to the other end of the resistor like this. Okay, so we have three resistances R1, R2, and R3. Right? They are connected like this. Then this is a series combination. Okay, one end. So resistances will have two terminals. Resistance has two terminals, right? So one end is connected to the other end, and then the other end is connected with the other end of the other resistor. And this is called series connection. Huh? Let us say I have these three resistances. Okay. So it has two terminals, like joining. So this is connected here. Then this is connected here. So this kind of connectivity. Let us have three resistances. Each pen is a resistance, right? Now the end of this pen is added or connected to beginning of the other. And end of this is added to beginning of the other. So now these are connected in series. Understood? Okay. Now let us see what is parallel combination. Okay. What is parallel? Parallel combination. So both ends are connected with both ends of other. So we have one resistance here, one resistance here, one resistance here. Okay, we have R1, R2, R3. So what is happening in parallel combination? This is the resistance. Now we have to apply some potential difference. So because without potential difference, no current possible, right? This is P. So you have potential difference and P, right? So now how the current will flow like this. Now in this case, the same current is flowing, right? But in this case, this current will flow here and it will change. So it will be I1 here, I2 here, and it will be I3 here. So the current is splitting here, but what is remaining same? The potential difference is same across all the three resistances. In a parallel, yes, because same potential difference is applied across all resistances. But here, the potential difference is different. Over here, it will be V1. The total potential difference is this. But now it is splitting across the resistances. Okay. So you have how many potential differences? 2 or 3, right? So in the series, the current remains same, but potential is distributed. In parallel, Potential remains same, potential difference remains same, current is distributed. So no. So in series combination of resistance, same current flows through all the resistances, all resistors, through all resistors, all resistors. But potential differences is distributed. Distributed or divided amongst the resistors. Okay, so the potential difference is distributed or divided amongst the resistors, right? What about parallel combination? In this case, what remains same? In this case, yes, the potential difference across the resistors remains same, right? But current is distributed amongst the resistors. Amongst the resistors. So understood? So what is the main equation here? The main equation is V is equal to V1 plus V2 plus V3. Here what is the current? I is equal to I1 plus I2 plus I3. Understood? In case of so now what is the equivalent resistance? Let us say I replace this circuit. Okay. So what is the equivalent resistance of R1, R2, R3 in series? Right. So imagine I replace this circuit with something like this. RS, R series. Okay. Just one. So what is the relation? That's what we need to find. Same potential difference. Now I am replacing a equivalent resistance instead of R1, R2, R3. So how do we get it? Now see. So by Ohm's law, right? By Ohm's law, what is V now in this case? IRS, right? So by Ohm's law. V is equal to IRS, right? And V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Correct? So just substitute. So therefore, IRS is equal to IR1 plus IR2 plus IR3. So what do I get? Therefore, R series or the equivalent resistance of series combination is just the sum of resistances in series. Correct? The equivalent resistances If I replace these three resistance with just one equivalent resistance, then that value is nothing but I have to use one resistance whose value is equal to sum of values of these resistances. Is that clear? So what is RS? RS is equivalent resistance in series. Equivalent series resistance. Okay, that's RS. Now likewise here also, if I replace all these resistances just one resistance, so I will have just one parallel resistance I am calling RP. Right? So what will happen now? And this was the voltage here. So again I will apply Ohm's law. So if I apply Ohm's law in this circuit, what is I? I is V by RP. Right? So by Ohm's law, I is V by RP. Right? And what is this? I1 will be V by R1, V by R2, V by R3. So V will be cancelled, right? Because here potential is same across all the resistors. So what do I get? So I get therefore 1 upon RP is equal to 1 by R1 plus 1 by R2 plus 1 upon RP. Okay. So the equivalent resistance in parallel, what is RP? RP is equivalent resistance in parallel. Okay, so I have explained both combination of
RP equal to R1 plus R2 plus R2. RP equal to R1 plus R2 plus R2.
no, 1 upon RP is equal to. So RP is equal to 1 upon this. Right? So should I write this? What is RP? Okay. What is RP? Look here. Therefore, RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Understood? What is RP? Reciprocal of this simplification. Okay. So after this step, this is the last step. Yes.
So, sir, as long as the circuit is in series, the current should be same.
Yes.
But if it's in parallel, it will divide.
Yes. Current will divide. And in series, the voltage will divide. Both the resistance. That's the funda. Okay. So if this funda is clear, then we have sorted. So what is getting divided in series? Potential difference. What is getting divided here? The current. Okay, that's how we got this equation. Current is sum of divided current. This applied potential is sum of divided potential difference. Okay, so that's why I tried to do side by side. So you have good comparison and you know how to calculate. So this is the equivalent circuit. Right. So what we have done, just removed all and put with equivalent of the parallel resistance. Okay. So that parallel resistance would be this. So online student, it doesn't end here. Okay. The last step is this. So in the textbook, how will you know what is the voltage? You apply 3 volt meter individually. right? Here you apply 3 current meter individually. So we can measure it with the help of different voltmeters. E1. So here you have E2. In the activity, you will see this, right? You have to know how to measure it. And I can just have one ammeter here. So I will know the current. Current anyway is same to all the places, only the different voltages. How do I measure current and voltages here? So I will use 3 ammeters here. Understand? So I'll have A1, A2, A3, 3 ammeters. And to measure the potential difference, I can just have one ammeter and 1 voltmeter over here.
So this voltage or scalar.
Yes, these are all scalar. So in the electricity, the sense of direction is not in the sense of mechanical quantities like force, etc. Okay, it will be like high level and low level in that sense. You will have the potential can be negative, so it's relative, right? So it can be negative with respect to, see, for example, if it is -5 volt, okay, and -2 volt, right? Which is higher potential? -2 is higher. Okay, so relative, it's all relative. Got it? That way, even though it is negative, but -2 is higher than -5. Right? So the current will go from 2 to 5. That way. Higher level to lower level. Got it? Okay. So shall we take a break? Yeah, it's. When is the break? 3 minutes. So any other questions if you have? Any questions? Online students? How is the board looking? Is it looking good? Board is colorful. Huh? So you feel like studying something. Now it will be solving numerical. You will feel enriched. So any doubts? So when you read the notes, then you will have doubts. It's all the numericals.
So this chapter will be about how it measures current.
No, you will read that in 12th standard. The functioning of ammeter and functioning of voltmeter is not in this class. Right now, you are just using it to take readings. Okay, but function details are not in school. You, any question? So how are you finding this chapter as compared to optics? This is harder. So we just started that.
This is a very big concept.
It's a different one.
We have seen light in everyday life, but we haven't seen the message.
So it's a bit subtle, right? But you see the effect, right? The pen is running. How is the pen running? So if you stop the current, then will not run. So for in our body, blood is running, right? So blood is circulating, right? That's how we are alive. So for anything to be functional, something has to be moving in it. So this is what. So that thing in electricity is current. And to move that current, we need mechanism. So that moving mechanism is potential difference. How do we get potential difference?
We start getting to the power plant.
Utility numbers. electrical companies, right? Who is producing electrical energy for us? All the electrical companies. Like here, you get a bill from. Are we getting power from Tata, Reliance, MSCB? Go home today and check your electricity bill. So MSCB is not the power production company, it just distributes it. It is a distributor. Maharashtra State Electricity Board, it just distributes it. Who produces it? Yeah, it's like farmer produces agricultural produce, right? But in the market, the retailers are selling it. They are not producing that crop. They are only selling it. So like that, MSCDC is only selling electricity. Electricity is produced in DRC, through nuclear power plant. Likewise, you have Adani, you have Reliance, you have Tata's. They are the actual producers. And government buys from them and they are giving it to us. It's like, okay. So it's same. When you compare it with life now, just the in comparison, you actually get the perspective a lot more. Okay? So it's not hard. It will become easy. Okay. So I'll see you after the break. See you after the break.
मैंने सिर्फ एक ही एक्सरसाइज किया दूसरा वाला मेरे को याद नहीं है क्या मैंने मेरे को अगले पीरियड स्टार्टिंग होगा एकदम चलेगा सही बहुत हो गया ये इसको पता हो गया
Okay, is everybody ready to solve numericals? All right. So first, let us list down all the formulas so far. So first, write down all the formula summary this side. Right. So what is the first formula? Current is equal to Q by T. Right. What was second? Q is equal to NE. Right. What happened? Huh? Is the ICSE batch. You have what next? B is equal to IR. Okay. Therefore, R is equal to rho L upon A. Right. Fifth, combination of series is sum of resistances. Equivalent resistance in parallel is equal to 1 divided by this is what it is. Okay. So this is so far we have learned this much. Okay, so let's start with numerical number 1, which is on page 200 NCRT. Page is 200. So example 1. What is it? So everybody read in your textbook a current of 0.5 ampere. So first write down the given data. I is equal to 0.5 ampere. Is drawn by filament of electric bulb for 10 minutes. T is equal to 10 minutes, which is equal to 10 into 60 seconds. Okay. Find the amount of electric charge that flows through the circuit. So Q is equal to 1. So we have I, we have T, we have Q. So which formula?
I equal to Q by T.
Yeah. The solution. I is equal to Q upon T.
Can we also convert that ampere into milliampere?
No, what? Ampere is the SI unit, no? Why milliampere? You have to convert milliampere into ampere. Right? So what is I? 0.5 into T. So 10 into 60. 5 6 are 30. So Q is 300 Coulomb. Okay. So you can write capital Q, small q, whatever. Right? So then you have in text question 1 and 2, you can answer yourself in text. Question 3. Calculate the number of electrons constituting 1 coulomb of charge. So you use formula 2. Right? So question 3 says Q is equal to NE. Q is equal to NE. So 1 coulomb is equal to N into what is E? 1.6 into 10 raised to minus 19. So N is equal to 1 upon 1.6 into 10 raised to minus 19. So when you simplify this, you'll get 6.25 10 raised to 18. So there are electrons. Okay. So how many electrons are there in 1 coulomb? Okay, so this I think we have already discussed in the theory. Next come to page number 202. So we have you written example 1, everybody? Online, can I erase? Okay, so first part I am erasing now. Now come to page 202. So we have example 12.2. Example 12.2. What is it? So how much work is done in moving a charge of 2 coulomb? So work is equal to what? Q is equal to 2 coulomb. Across 2 points having potential difference 12 volt. So very simple. What is the relation? See, forgot to write potential. Okay, we forgot to write potential formula, right? What is V? There's one more formula, right? V is equal to W by Q. Very important. The most important formula, right? So now the serial number changes. So this is 2, 3, 4, 5, 6, 7. Nobody remind me about this formula, right? Potential difference formula. So since V is equal to, so what is W? Therefore, W is equal to QV. Okay. From second formula. So you have 2 into 12. 20 more joule. Right? So this is 20 more joule. So I'm just writing a formula number, right? To this, there is this formula from potential difference formula. Okay. Now let's look at in-text question. Name a device that helps to maintain potential difference across a conductor. Cell. Voltmeter just measures it. Name a device that helps to maintain potential difference across the conductor. Keep your mic unmute online. All of you, unmute your mic. So name a device that helps to maintain a potential difference across a conductor. It is cell or battery. 2. What is meant by saying that the potential difference between 2 points is 1 volt? Right. So in text question 2. In text question 2. So we have V is equal to work done per unit charge. So what is meant by potential difference of 1 volt? So when 1 joule of work is done in moving a charge of 1 coulomb between those 2 points, right? Then we will say that the potential difference between these 2 points is 1 volt. Understood? If in moving a charge 1 coulomb from here to here, if the work done is 1 joule, then I would say potential difference between point A and B is 1 volt. Okay? So when 1 joule of work is done in moving 1 coulomb charge between the 2 points, then the potential difference between the points is 1 volt. So you have to know how to write the answer in English. So how much energy is given to each coulomb of charge passing through 6 volt battery? In text question 3. We have in text question 3. Question is how much energy? So work and energy is the same thing. So again W is equal to QV, right? So from this formula, or W is equal to QV. Okay. So work is energy. So this is equal to each coulomb, meaning 1 coulomb, and it is passing through 6 volt. Okay, so it will be 6 joule, right? So meaning when you are passing 1 coulomb of charge from here to here, 1 joule of energy is given to the charge itself. So the energy gained by the charge when it is moved from A to B, it will have kinetic energy. Here the charge was stationary, but now the charge was moving when it reached B, so it will have kinetic energy. So that energy is equal to 1 joule. Understood? So when 1 coulomb is charged, is moved through a potential difference of 6 volts now, then it will have not 1 joule but 6 joule of energy. Got it? Because work is energy. Okay. Therefore, so I hope you have understood. I am not going to write that again. Right? Okay, now let's come to example 12.3 on page 208. page 208. Right? So we have. If anyone has any doubt, please ask. How much current will an electric bulb draw from 220 volt source? So we have to find out. So example 12.3a. So we have to find what is current given V is equal to 220 volt. So given R is equal to 1200 ohms. Right? Okay. So A, right? That's A part of the problem. So let's solve it part by part. So solution. So what do you have to find I? So by Ohm's law, since where V is equal to IR, by Ohm's law. Okay, so remember Ohm's law, right? Therefore, I is equal to V by R. So now substitute, what is V? 220 on 1200. How much is this?
0.183.
This is 0.18. Okay. Now, what is the next part of the question? B. 12.3 B. How much current will an electric vehicle coil draw from 220 volt source if the resistance of the vehicle coil is? So in this case, we have to find current equal to what? B is equal to 220 in this case, and R is equal to 100. So again, current is equal to V by R. This means 220 upon 100, which is 2.2 right? So you can see when the resistance was high, right? Less current flew through the circuit. When the resistance is low, more current has flown through the circuit. Okay? So do you get the idea? Current is inversely proportional to resistance. Current is inversely proportional to resistance for the same potential difference. Okay? All right. So when the potential difference is fixed, current will vary inversely with resistance. Okay? Right. So this is the learning from this example. So if VD is constant, then current is inversely proportional to resistance in the same circuit. Now let's complete. Okay, are you writing? Done writing? So these examples are solved in your textbook. So you can write a note there instead of writing. All right. Everybody has written down this formula.
Yes.
So this is the technique you should follow. Have once the chapter is over, okay, make one page and write down all the formulas in that chapter before solving dimensions. Okay. So then you will not waste time. You will be able to quickly address. Okay. Can I erase it? Okay. Shraddha. Yes. Arya. Arya, are you there or? Yeah, okay. So I am now erasing all the formula. You have the formula ready with you, right? So I can solve more equations. Okay. Let's do example 12.4. So what do we have? The potential difference between the terminals of electric heater is 60 volts. So here given E is equal to 60 volt. This is 12.4 on page 208. So when it draws a current of 4 ampere, what current will the heater draw if the potential difference is increased to 120 volt, right? So now V dash is 120 volt, right? So in that case, what is the current drawn by the heater? Okay, now what does it mean? What is the potential difference across the heater when it was drawing the current 4 ampere? Right? So what do we get from this? We get the resistance of the heater. The resistance of the heater does not change when the potential difference across it is increased. Okay? So this means R of heater is equal to V by I, which is resistance is potential difference by. So this is 60 by 4, which is 15 ohms, right? Okay. So the resistance of heater, R is the resistance of heater. Now resistance is the constant for the heater because heater is not changing, right? Which is constant for a given heater. Constant of it, which is constant for it. Constant for given heater. Right? So in this case also, now when the voltage is increased by 120 volt across the heater, so resistance can be, same value of resistance can be used, right? So therefore here, from here, R is equal to, what is I dash? I dash upon R, which is 120 upon 15. Now how much is this? Just find out how much is that. 8 times. Yeah. Okay, so this is 8. Right? Because the resistance of the heater is a constant. So we'll use the same value of resistance there. Okay, so anybody has difficulty understanding this question? Huh? All of you got it? Please just don't copy. Try to understand and ask in case you are not able to. Okay. Now let me move on to question 12.5. Question 12.5. So 12.5, resistance of a metal wire of length 1 meter is 26 ohm. So you have L is equal to 1 meter, R is equal to 26 ohm, right? At 20 degrees Celsius. Okay, so the temperature is here. If the diameter of wire is 0.3 ohm or 3 millimeter, B is equal to 0.3 millimeter. What will be the resistivity of the metal? Resistivity is equal to what? Using table 12.2 predict the material of the wire. So first we'll find out the resistivity, then we will match with the table. Okay. Right. So solution. What is the formula for resistivity? So we have R is equal to, since R is equal to rho L by A, right? Therefore, rho is equal to RA upon L. Okay? So this is R upon L into, now area of cross section of the conductor will be circular. So it will be pi d by 2 square, correct? Okay. The area of cross section of the wire is circular, right? So what is the area of the circle? Pi r square. So what is given? Diameter. Okay. So how much is this diameter? This is 0.3 into 10 raised to minus 3 meter. We will convert that in meter. Therefore, what is rho? Rho is equal to R. What was R? 26 ohms. R was 26 ohms. Yes. Then upon L. L is 1 meter into pi, which is 3.14 into d by 2 square. What is d? 0.3 into 10 raised to minus 3 upon 2 squared. Now solve this. How much do we get it? We have 26 into 3.14. So we have 0.09 into 10 raised to minus 6 upon 4. So solve this. How much do you get it? So you should get it 1.84 into 10 raised to minus 6. Right? 1.84 into 10 raised to minus 6. Just verify if you are getting this answer. Yes, sir. Are we getting this answer?
Yes, I got 1.83.
So 8, 3, and if you go, it should be greater than 5. So when you round it off, you get 1.8. Go for one more decimal, so it should be greater than 5. 1.836 something will be. Okay. Should I calculate it for you? So it is 26 into 3.14 to 0.09 divided by 4. Yeah, so it is 1.8369. That's how you get it. Okay. So what metal is this? Huh? Yes, 1.81 into 10 raised to minus 6 is manganese. Okay. This value is matching for manganese. Is everybody with me? Are you all with me? Yes. Okay. Wonderful. Jamshed? Any difficulty, Jamshed? Okay, ask me later then. Can I proceed further?
Wait a minute, sir.
Yeah. Give me a go ahead, when done. In the meantime, you all have any difficulty? Sure, you? Because okay, so shall we? Has everyone understood this step? The diameter of the wire is given, so cross-sectional area will be pi r square, right? So it is r is diameter by 2. Okay. Shall we proceed? Jamshed? Jamshed is not responding. Nor Arya?
Yes, sir.
Jamshed, are you there? I think it's nonsense. Okay. Next is we have 12.6. A 4 ohm resistance wire is doubled on it. Calculate the new resistance of the wire. Now this is a wonderful question. Right. So you have sample 12.6. So what is the question? Let me write. 4 ohm resistance wire is doubled on it. Calculate the new resistance. Okay. Solution, all of you. So you have a wire, right, with some length and some cross-sectional area. Let us say its length was L and its area of cross-section was A. Okay, so what is the area of cross-section? This was A. Area of cross-section, not diameter. Okay, so where is L? L is length of the wire. Is area of cross-section. Right? So what was the resistance given? R is equal to 24 R1. So let's call this L1, A1, and the wire was in this shape. Now wire is doubled onto itself. What has been done? This wire is now doubled onto itself. Right? Like this. It is doubled onto itself. So what is now the new area of cross section? So this becomes L2. Right? And this becomes A2. Right? So what is the relation between L2 and A2? So A2 is equal to 2 times A1, isn't it? What is L2? L2 is equal to? Yes, L1 by 2. Right? So what is the new resistance? So therefore, what is R2? R2 is equal to what? That's what you do. How will you do it? Is the material changing? No. So it will remain rho. Rho for this, rho for this. So now using, so therefore R1 must be equal to rho L1 by A1 and R2 is equal to rho L2 by A2. Right? So taking ratio, since the material is same, so resistivity is same. For same material, since for same material, rho is constant. Okay, so what will happen? Taking ratios, then R2 upon R1 is equal to rho will get cancelled and 2 on A2 into L1 upon A1. Okay, rho will get cancelled. Right? When you take ratios R2 upon R1, now rho cancelled, we have L2 by A2 into L1 by A1. Right? So now substitute. So what is L2? L2 is L1 by 2 And A2 is 2 times A1 into A1 upon L1. This can you get 1 by 4. Therefore, what is R2? R2 is equal to 1 by 4 times R1. Which is 1 by 4 into what is R1? 4. At 1. What is the answer? 1 ohm. Is that the answer? Yeah. So what we will do? So when the wire is doubled on itself. This is what we get. So its length becomes half, the area of cross section doubles.
We couldn't have said that R is directly proportional to that of conductor. So if that is one of that.
That's what we are saying now. Those relations are captured here. It's not only length, there are length and area. So there is an inverse variation. So when length reduces, area increases. Because the volume is constant. Right? So have you understood the logic? Now the same question, if I would have asked you, the length is doubled, then what is the new resistance?
Then it will be
It will be 8. What about area? Area will be doubled when you increase the length. Volume is constant, right? Exactly. So this is the thing. So you can solve this question in 2 ways. Mathematically, by keeping the volume constant, you find out the area. Generally, only length is given. Length is doubled or half. Then there is a proportionate change in area also, as per the inverse relation. So you have to calculate the area for the new one. And then take the ratio. Do the question. I am giving a question. Same question, length doubled. Do it. Exercise. Exercise. In the above question, find the resistance if wire is stretched to double length. Everybody tell me the answer. See, earlier the wire was doubled on itself. So read the question carefully. Now the wire is stretched. So what is the new wire now? The new wire after stretching is this. Okay, it's almost twice the length. Find the answer. How much you got? 16 times.
4 times 16 ohm. So 4 times the original resistance, which is
This is 16. Yes. So everybody getting 16? So in this case, what is happening? So from this, you had written this? Everybody had written this? Okay. So for this question, what changes will you make in this? You have L2 is equal to 2 times L1 now, when the length is doubled, and A2 is equal to A1 by 2, half of it. Okay, because it is doubled, the area will become half now. If length is half, area will be doubled, right? So now substitute. So what do you get? So you will have L2 is equal to 2 times L1, or A2 is equal to A1 by 2 into A1 by L1. So this will be 2 by 2 is 4. Right? So R2 by R1 is, this means R2 is equal to 4 times R1. This will give 4 into 4 into 16. Okay? So we have just modified the question to get a different answer. So you see, when it is halved, the resistance decreases, but when the length is pressed, the resistance increases. Okay. All right. So with this, area, what about area? Area is half. So area is half. So A1 by 2, 2 will go in numerator, no? And L2 is anyway 2 L1, so 2 into 2 will be 2. What is the question? Is it mathematical simplification? Okay. So A1 by 2, that 2 goes in numerator, fraction. Right? Okay, so we are done with the numericals on remote combination of resistances, right? Okay. So on what factors does the resistance of the conductor depend? In text questions, page number 209. Length and length, area of cross section, right? And resistivity. Because material also, right? So resistance depend upon the dimension and material of the conductor. So if the resistance of a given conductor, means if the material is same, then it only depends on length and area. Okay. Question 2. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? So more area means less resistance, right? So current will flow more easily through thick wire. Okay? Because resistance is inversely proportional to cross-sectional area of the conductor. We have right. So opposition to current will be less. Plus the electron is getting bigger cross-section to travel. So it's like not a thin gate, it's a big gate for electron to travel. Okay. Question 3. Let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half of its former value. what change will occur in the current through it? Yes, because there is a direct relation. V is directly proportional to I. So if V is half, I also will be half. Okay. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal?
Because they are conductors and they have less resistance with respect to.
So it can withstand more temperature without burning. Alloys have a property that they can withstand.
Alloys will not oxidize or burn.
Yes, so it will not get oxidized, means it will not burn.
Less resistance, so heat will not be.
What less resistance? Why less? You need more resistance. Toaster, you need more heat. Alloys have high resistivity. See the table. So you're giving a totally different answer. Alloys, they will not get oxidized, means they will not burn at high temperature. No, heater need to be at a very high temperature. So what is the property of alloy? Read the paragraph above table 12.2. So alloys do not oxidize, that is burn readily at high temperature. That's why. Got it? Okay, so why are coils of electric toaster and electric iron made of an alloy? Because alloys do not burn at high temperature. That's why, that's the answer. Whereas pure metal will burn at a high temperature. Okay. Question 5. Use the data in table 12.2 to answer the following. Which among iron and mercury is a better conductor? Which has lower resistivity, right? So, correct. So iron is a better conductor because its resistivity value is 10 into 10 raised to minus 8, whereas mercury is 94. So it's almost 9 times more resistance than iron. Which material is the best conductor? Silver, the lowest resistivity. Okay. So in the end, it is given, you need not memorize these values, so don't get overwhelmed, right? So all this data will be given to you in the numericals. You don't have to memorize anything. But what you have to memorize is all the formulas that I have given you, all the relationships. Okay? So, all right. So with this, let's move on to solving numericals for combination of resistances. Okay? Ohm's law and combination of resistances. Chalo. Huh? Page number 212, example 12.7. Now, okay. So example 12.7. The class is still 10:45. 10:45 now. So example 12.7. Page is 212. Okay. So an electric lamp whose resistance is 20 ohm. So to draw this circuit diagram. So you have one. this is our circuit diagram, and this is the cavity. So you have plus and this is minus. Right, so what is the direction of current? Is the direction. This is minus plus. Right, what is given in the question? The electric lamp with resistance is 20 ohm. So the resistance of electric lamp is 20 ohm. And conductor of resistance of the conductor is 4 ohm. It is shown here. So the entire conductor resistance is shown as 4 ohm. This is connected to 6-volt battery. Right? Calculate A. Total resistance R total. Right? And you have current through the circuit. B, you have to find current. Then you have to find potential difference across electric lamp. Across lamp and B and conductor. Okay, these are the things you have to find out. What is the potential difference across the lamp? What is the potential difference across the conductor? So how will you do it? Now see, is this a case of series or parallel? Series. So the conductor resistance, the full conductor resistance is shown here. So there will be, this is the conductor, right? So I am writing BC. Okay. So conductor, that is BC, and for VLAN say L, right? And so here BC and here it is VL, and V is equal to 6 volt. Total applied potential is 6 volts, right? Now, so what is R total? R total will be resistance of conductor. That is, let's call this is resistance of conductor, and this is resistance of lamp. Okay. So, what is R total? R total will be RC plus RL. Since series, in series, RS is equal to R1 plus R2. So in series, the resistance, the total resistance is just the sum of all the resistances connected. Okay. So how much this value will be? RC plus RL is 4 plus 20, that is 24 ohm. Right? Now what is I? Now your total resistance is, so total resistance is 24. So I is equal to V upon R total. So this is 6 upon 24. So 1 by 4, which is 0.25 ampere. Right? So current is 0.25 ampere. Now, what is VL? Current is same, right? So VL is I into RC. So this is 0.25 into 4. And this is 1 by 4 into 4, which is 1. What is VL? 1 volt. So now I can tell, so 1 is here, so remaining will drop here, that is 5, right? But we can calculate it also. So V bulb is load, is equal to I into R load. So this is 0.25 into 20. This is 1 by 4 into 20, which is 5. So I need not have done this because 1 is out of 6, if 1 is dropped here, then remaining will drop or remaining will be distributed across all. So any difficulty in this? Okay, so we just did the problem for combination of resistances in series.
So, in backing the current series, the voltages add batteries.
That problems voltage will just will add.
What is the current?
And that's out of school. I'll read that. Asking all head questions, but outside is better. So do you read order percentage books?
I gave competitive exams to the
That's why you have to read. Because generally I'm not seeing students asking such questions. What is the exam you have read?
yes, I gave last year.
Which one you gave last year? Okay. Yeah, so generally they ask, questions from like more application-based questions and questions from 12 months. That's what we do. This is what these ICSE course also do. They teach 11, portion in 10, 10 portion in 9. Okay. So you have to wait till 12. I'm not going to discuss that in 10. Okay. Any other question related? Shall we proceed? Okay. So others also like read as much as you can from other sources, right? Apart from CBSE. Although CBSE is the gold standard for all competitive exams, but just CBSE is not enough, right? So go for some supplementary questions as well. Okay. Next is right. So can you try the in-text question? What's the answer you get? Let's do in-text question. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, a 8 ohm resistor, and a 12 ohm resistor. A plug key, all connected in series. Everybody, page 213, right? In-text question 1. So all online students also draw the circuit and show me. I'm giving you 2 minutes to do this. So read the question here. You want a textbook? I studied the question there. Yes. I can't give you mine because I've drawn the circuit. Online students, once you've completed, just let me know. Plug key should be,
open or closed.
what is given in the question?
And a plug.
Closed. They have not mentioned anything, now open or closed, so you close it.
We have to show now multiplicators and
Is it mentioned? No. Bring the book also. Bring the textbooks. Very nice. Just go back to the searches. What's the name? Akshay. Akshay. Okay. What about you, Aditya?
also like it was
First we already did. Okay, so so we have not drawn the current direction. What is the current direction? We're trying to next one. So battery don't write DPV, write the sum code. Yes. Clockwise, starting from the left of the positive terminal. So any of you have completed online? Yeah. Show me the diagram, Shraddha. Yes. Correct. Correct. Next. Arya. Yes. K. You're right. K. Label the diagram as well. Huh? Yes. Current direction. So you're writing R1, R2, R3. Write the values. Is everybody's diagram like this? So when you connected the cell in series, right? And the current direction like this. So 5, 8, 12, right? So 5 ohm, 8 ohm, 12 ohm. Is this what it is? Okay. Right. So everybody's got it. If you want, you can mention it like this. Jamshed, yes. Jamshed has dropped out. Okay, Arya, have you drawn the circuit? Is it like this? So you have to label it also, okay? I think you have to label it. Okay. Now, next question is redraw the circuit of question 1, putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across 12 ohm resistor. Okay, what would be the readings in ammeter and voltmeter? So now, so this was in the first question. For the second question, I will just modify this diagram. So this was the first question. Second question, so you just have to put a voltmeter over here, right? So this would be negative and positive. And for current, you can put current anywhere. You can put it here also, because current will be same in the circuit, right? So you have an ammeter. This is minus. Now you have to find out what is the voltage across this and what is the current in the circuit, right? So how will you find the current in the circuit? So now this 6 volt is divided here, V1, V2 and V3. Okay, but what about current? So total current is equal to V by RT, right? What is the total resistance? Just the sum. So V is 6 divided by R is 5 plus 8 plus 12. Okay, because in series the resistances just get added. So I is equal to 6 upon 25. Right? So how much is this? 0.04 into 6. This is equal to 24. Right? So you'll get 0.24 ampere. So what is V3? V3 is equal to, right? So this is the first part. Current is equal to, what is V3? And V3 is equal to I into 12. Because R is 12. What is I? 0.24 into 12. How much is this? 12 goes up 48. 48.
288.
So the voltage across this resistance would be 2.88 and the current is 0.24. Okay, that's what it is. Right? Okay, so next is we'll do example 12.8 and 12.9, and then I'll let you do the index question as homework on page 216. Right? Let us do example 12.8 also. Is it done? Can I erase it? Okay. What are you writing? Okay. Next is. So is it making sense to you? Example 12.8. This is on page 214. In the circuit given in diagram 12.10. Where is 12.10? So here 12.10 is this. So draw the circuit diagram. We have 3 resistances. Right? They are all connected in parallel. Okay. Then there is a potential difference applied. E, ammeter, circuit complete. You have a voltmeter applied. I'm taking the voltmeter above. It doesn't make any difference. I'm just taking it up. Because there was no space. So what about the polarity? Plus, minus. Okay, so we have R1, R2, R3. Right? And this is how the current will flow. Okay. So this is our diagram. So what is the question? So in the circuit diagram, suppose resistance R1, R2, R3 have values 5, 10 and 30. So it is given R1 is equal to 5 ohm, 10 ohm, and this is equal to 30 ohm. Which have been connected to battery of 12 volts. So V is equal to 12 volt. Right? So you have to calculate, find a current through each resistors. So let's call current as I1, I2, I3. I1, I2, I3. You have to find I1, I2 and I3 is equal to what? Total current in the circuit B. I is equal to what? Right? Total circuit resistance C RT, right? Because our resistances are parallel. This is what you have to find out, right? Now, what is I1? So potential difference across each resistance is same, and it will be equal to the total applied potential difference, right? So A. Let's solve it. So in parallel connection, potential difference across each resistance is same. That is 12 volt. So what is the potential difference across each resistance? 12 volt. So therefore, what is I1? Therefore, I1 is equal to V upon R1, which is 12 divided by 5. Right? So how much is this? 5 2s are 10.4. Now what is I2? V by R2. V is same, 12 by 10. 1.2 ampere. Right? So when the potential difference is same, resistance double, current half. V by R3. So this is 12 by 30. So this is 0.4 ampere. Okay. So what is I? Now I is nothing but sum of all the I2. I is equal to I1 plus I2 plus I3. Right? Because the same I1, I2, I3 was distributed. So this is equal to what? 2.4 plus 1.2 plus 0.4. So how much is this? 1. Huh? Is it 4?
Yes.
4 amps. What is RP now? So what is RP? Now I need RP must be the equivalent resistance. So RP I can get it from I and P itself. So RP is equal to V by I. 12 upon 4. So this must be equal to 3 ohm. Got it? So I need not go for 1 upon 1 by R1. You can check. If you do 1 upon 1 by R1 plus 1 by R2 plus 1 by R3, that also will give you the same result. You want to do it? Let's do it. So RP is also equal to 1 upon 1 by R1 plus 1 by R2 plus 1 by R3. This is 1 upon. So 1 upon 5. 10 plus 1 upon 30. Right? So this is RP. So what this will be? So what is it? So what is the LCM of this? 30. So 6, 3, 1. So this is 30 divided by 6 plus 4, 10. This is 3. So do it either ways. The resistance value will be 3 ohm. So you can use Ohm's law here directly because now you know the total volt and total current that gives you RP, or you can use this formula. So we have calculated RP using two methods. Okay. So this is or. Either do with this or with this. Right? So can you try the next one yourself? The solved example and the index question. I think enough for today. We won't be doing anything else today. So students, you can try the next question yourself and the in-text question. Okay? The in-text question is homework for today.
What page number?
Page number 216. So write down the homework. In-text. Page 216. So if some 5 questions are there, you can try that. So what is remaining is a small portion, which is in the next class, I think electricity will be able to finish the chapter. So solve more and more devices. When you use cell, it is DC, direct current. But when in ohms, the main supply is AC. So
India main supply is this.
yeah.
I think it is this.
Oh, no, everywhere it is DC. Wherever cell is used, it is DC. Our AC supply frequency is 50 Hz. They have 60.
Transmission
Transmission is efficient. If it is AC. AC is very risky also. High DC current can kill immediately, but AC will be safe because cycle changes them. So once the current the shock is connected with you. When the cycle changes, you get a chance to come out. So it's not the case with DC. DC will finish you off just in one go. Okay. So,
But lot of appliances are DC. Lot of appliances which needs a battery.
anything which uses a battery is a DC. But then your home appliances are AC, right? When there is power outage, that time you are using inverter. Have you heard of inverter? Yeah, so inverter is a DC. So there is a way to convert is DC to AC. Okay? Inverter does that. And generator creates AC. Okay, so there is a way to and from AC to DC because your mobile is DC. So it's called rectifier. The adapter has so you can do AC to DC conversion as well as DC to AC. That's possible. So if you have one type of supply, you can convert it to desired form of supply. So in human life, we have language interpreters or converters. So these things are applicable in all blocks, right? But there is a different method to do. So are you liking it? Are you feeling that stepping closer towards being professional?
In research profession.
No, what I'm saying is now the way you used to study like before 9, now the way you're studying, is it some difference? It's very broad, huh? Okay, I'll ask you when you reach 11 and 12. So if you do your 9th and 10th well, okay, 11, 12 will not be very difficult. So do it well. Achha, don't take too much stress for clearing the exam. Okay, make all the effort to understand things. Exam clearing is just a byproduct. What students do is they just take so much stress over the exam. Exam is just one event, okay? So what you do the entire year, right? That's what counts. Take it topic by topic, understand all the concepts. Feel free to ask wherever you're stuck. Okay, then, so we'll meet next week. Do you have extra lecture next week as well? This week you got 2 extra lectures, right? Generally there was only 1 lecture per week. We met thrice this week. Isn't it? We met on Monday, yesterday, and today. So 2 extra lectures this week.
Directly on the
Which day is that? Should be same day. That's great. Thursday, right? Or Monday? No, it should be Monday. Yeah. Okay then, so see you in the next class. Right? See you in the next class.
Okay. पेज खत्म होने वाला था और पेज खत्म होने वाला था तो मैंने वो दूसरे को ले लिया आज सुबह बैठ किया तो ऐसा आईसी सुना हुआ ना ऐसा विकास करती है सारा कुछ इसको थोड़ा सा मदद है हमारे स्कूल में बड़े हमारे स्कूल में सब लोग को अपना जल्दी समझ नहीं आता इसके टाइम लगा के करते हैं इसका जनरेशन में खराब हो जाएगा सब लोग फिर क्लास में शुरू में एक बार लगी सिलेबस में लोग पढ़ने का टाइम स्कूल वाले में करते हैं बंद हो जाए
Good morning. What was the homework? Sorry?
The question number 1, 2, 3, 4, 5, and 12
Yesterday I did the homework in another because I did not have any when I went back the rabbit.
Here's your homework doubts.
So exercise 4.5, exercise 4.
A person on tour has 360 wall. He has 360 for his daily expenses. If he exceeds his program by 4 days, he must cut down his daily expenses by ₹3. Find the number of days. What's the total money he has with him?
360.
Let his tour be for X days. So what is the amount he spent in each day?
360 rupees.
Huh?
So he's spending 360 rupees.
Sorry. For his daily expenses for each day. Right? Yes, so now
X.
if he X
X plus 4 minus 3. X
I've written that there.
If we exit this 4 by 4 is, which is x plus 4. Is to cut down daily expenses. So it will be minus 12. Right? Yeah. 12 rupees. 12 rupees for each for 4 days.
So he will have to cut down his daily expenses by ₹3
per day. So it's
So
4 days.
देखो अगर अभी वो 20 रुपीज स्पेंड करता है तो अगर उसका नंबर ऑफ डेज बढ़ गया तो उसको सपोजिंग यू हैव टू कट डाउन हिज डेली एक्सपेंसेस बाय ₹3 17 रुपीज स्पेंड करना पड़ेगा बराबर है ना वो कैसे करेंगे इसको यस
So I made this question where I thought the total expenses was basically.
Yeah, it is for daily expenses. Yes,
Then
360 upon X.
Yeah.
Yes,
According to question 360 upon x minus 3 will be equal to 360 upon x plus 1.
minus what 3?
Yes, because 3 rupees less.
जैसा भी ले लो, you can take it like this also. Oh, somewhere. It's like saying that 20 becomes 17. 20 minus 3 is equal to 17. Basically. When you take it as an example, it comes to your mind immediately. Next round. Now here, tell me we have done the first sum.
First 6, 8, 9, 10, 11, 12, 13, 15.
Now we'll do second sum then.
Okay.
We'll go, which are the sums to be done? You tell me. Which are left? You tell me.
2, 3, 4, 5, 7,
2, 3,
4, 5, 7, and 12, and 13.
and 15.
The 15 will be marked.
15 be left, huh?
Yes.
We'll do 15 sum. Now see, a train travels at a certain average speed for a distance of 54 kilometers and then travels distance of 63 kilometers at an average speed of 6 kilometers per hour more than the first speed. If it takes 3 hours to complete the total journey, what is its first speed? Now see, let's write down the data. Distance when it is traveling at 54 kilometers per hour, let its speed be x kilometers per hour, right? when it travels a distance of 63 kilometers, let the speed be x plus 6 kilometers per hour. This is the data given to you. Okay, total time is 3 hours. So now we write how we start this sum. We have to find out this speed. Let the speed, the first speed be x kilometers per hour. Therefore, the new speed will be x plus 6 kilometers per hour. Now we write, we know that time is equal to distance upon speed, yes or no? By the given condition, time taken by this train 54 by x, yes or no? Distance upon speed. Plus, because the total time they are saying, 63 upon x plus 6 is 3. Do you understand this? Solve. Come on, do it. Finished?
Hello.
Arya, you've become the host again.
Hello, Arya.
Sir didn't came till now.
Shraddha.
हो गया? Done? नहीं आ रहा क्या? हो गया ना? चलो. Then we'll meet after the break. Then we have only 2 sums, right?
Exactly 500, yeah. Exactly. Instead of 500, exactly this kind of next month is 0. Yeah, we'll check the there was a pilot solution there. Minus 5 plus 2. This after this to get started this answer to there is a simple view of transfer here. Also, so this one is to write out this one is